Alrighty, Mr. Allen here with the one and only. Hold up. I'll make it big. River Dog Jenny. What up, Jenny? Any squirrels out there? Okay, cool. All right, well there we go. Yeah, so we're gonna do a little math here. All right, it did get a little chilly, as you see. I put on my Milwaukee heated vest. Okay, and yes, I have I cut a piece of wood up in Wisconsin, and it's behind me. I'm gonna make something with it. I don't know what, but let's do a little problem here with a triangle. We're going to classify by sides and angles. Excuse me. Now, on a test, you might give you the ordered pairs, and you have to plot them yourself. But I went ahead and plotted them. But I'll write my ordered pairs: -2, 6. It's a little hard to read. Then we have 7, 6, and then we have 2, 2. All right. So we need to classify by sides and by angles. Well, in any event, what we're going to need to do here is we are going to have to go ahead and do the distance formula for all of our sides. And I'm going to move this out of the way. We're going to move that down here. So let's go ahead and do that. All right. So if I want side AB, well, AB I can actually, what the? Hold on. All right, I think we're okay. It's like an update. Maybe I think they were trying to sell me virus stuff, you know, Norton. Anyways, back to it. Are we ready? So I have AB. I can just count that one out. So, because it's a horizontal line. I go from -2 all the way to +7. That's a distance of 9. Cool. I don't even have to do distance formula with that one. How about BC? Well, BC, I do need to do distance formula. So the square root of, and then it's 7 minus 2 squared plus, and then my y's would be 6 minus 2 squared. Boom. All right. So I have 7 minus 2 is 5, which squared would be 25. And then I have 6 minus 2 is 4. 4 squared is 16. So it looks like I have the square root of 35, 41. I'll just go ahead and leave it like that. And how about I do this? I'm going to put the lengths right on my graph here. So we've got 9, and I've got square root of 41. All right. Back to purple. So now with AC, I would have the square root of, and I'm going to have 2 minus -2, and it really doesn't matter which order I do them in, as long because I'm squaring them, right? So as long as I keep the x's together and the y's together, I'm squaring them. So even if I flip them, squaring them is going to make them positive regardless. Unlike slope formula, where if you do slope and you switch them around, then it can screw things up. Okay, little sidebar there. And then we have 2 minus 6. So I've got that becomes positive, so I get 4. So I have, let's see here, 4 squared is 16, plus, and then I have, again, actually, -4 squared is 16. So I get 32. Let me move these out of the way again. We'll just put them over here. Okay. Alrighty. So I get square root of 32. Now, square root of 32 can be simplified down to 4 root 2, but I'm not going to. There's really no point in this type of problem to do that. I'm not asking you for the side lengths, so as a final answer, I'm not asking for those lengths. You don't have to give me those lengths. You're using them to classify the triangle. All right? So I'm not even going to do that. Now, by sides and by angles, well, sides, they're all different lengths, right? So that is going to be scalene. Now, by angles, go ahead and let's see if I can actually, I don't know if I can do this. I'm going to see if my technologies work. Can I make this smaller? Oh. Let me try that again. Let's see here. Maybe I'll use my mouse. Ooh, okay. That works. Boom. Okay. So now I'm going to use my Pythagorean Converse. So I'm going to take my longest side. Well, I know that 9 is my longest side because if I took the square root of 41, that's between 36 and 49. So it's going to be somewhere between 6 and 7, right? Square root of 32 is smaller than that. So 9 is going to be my largest. So that's going to be my c squared. I don't know. And then I have square root of 41 squared plus square root of 32 squared. And as you can see here, squaring the square root of 32 is easier than squaring the 4 root 2. Like, that gets kind of confusing. We'll worry about that later. But now it's just, yes, sound effects are needed. And I get 81 I don't know. And then 41 plus 32, well, that's going to give me 73. This is greater than, it's very close to being equal, actually. It looks almost like a right triangle, but it is not. It is obtuse. All right, boom. Now, had you just had scalene and obtuse on your paper and you had 0 work to show for it, you would get 0 credit. Okay? You need to show work. You need to show me getting side lengths, and then you need to show your Pythagorean converse, corollary. Ooh, cool, wonderful, fantastic. Let's do another problem. All right, for this next one, actually, I need to put a question with it. There we go. Find the restrictions on x. So I'm given some general things here. It says the measure of angle C is larger than the measure of angle B. And as we did in class, what I did, which is unofficial, is I marked angle C with 2 arcs, and I marked angle B with 1, showing, hey, that angle C is the bigger one, has 2 marks. Again, that's not real official geometry notation. If that's on a diagram, you can't assume one's larger than the other. We're going to use it for ourselves, though. All righty. Does that sound good, Jenny? She's on squirrel watch right now. Okay, we'll give an update in just a second after this problem. All right, so then that means that AB is going to be my larger side compared to AC, right? Across from the larger angles, the larger side. The larger my angle gets, so these 2 points are this far apart. If I were to make this other one further, well, now that angle becomes larger, and then the distance between those 2 endpoints becomes larger as well, okay? Let's get that out of the way. Let's work on the actual problem. Okay, so I'm going to set up an inequality. I know that AB, which is 3x plus 5, is greater than 4x minus 1. My neighbors are probably wondering, what are you doing on a Friday night right now at 5:35 making math videos? Well, I'm living it up, okay? Right? YOLO. Yo-ro. You only round once. Okay, so I'm going to subtract 3x. And I'm going to add 1. I'm going to do that all in the same step. All right, so we get 6 is greater than x, or in other words, x is less than 6. Okay. Well, if x is less than 6, we're talking side lengths here. We do have to be careful about going negative, right? I don't want to go 0 or negative for my side length. So with sides here, I do need to make sure that nothing goes negative. Well, which side of these two is likely to go negative first? Which one will go negative first? Well, the smaller one's going to go negative first. So my smaller side being AC, I need to make sure that this right here is greater than 0. So I will set 4x minus 1 greater than 0. 4x is greater than 1, so x is greater than 1/4. So my final answer here is that x is between 1/4 and 6. Now you might be wondering, well, how come we didn't do like AB? Like I don't quite get that. Why did we select AC? I selected AC because it's the smaller of the sides. Therefore, if the smallest side, excuse me, I had to get a drink of water. The smallest side will be the first one to go negative. So I got to make sure that I keep it above that. Let's just take a look at the other one. If I took 3x plus 5 and set that to be greater than 0, like I did the other one, negative 5. Right, so 3x is greater than negative 5, divide by 3, and I get x is greater than negative 5/3. Okay, cool. So if I had that as my final right here, negative 5/3, well, if I selected, say, a value that's bigger than negative 5/3, how about something like 0? Well, if I plugged 0 into AB, I'd get 5. That's cool. But if I plug it in here, my length is negative 1. That's not okay, right? So I have to pick the smallest side, make sure that smallest side is greater than 0, and then I'm good. Because I know if the smallest side is greater than 0, then any side that's larger than that is also greater than 0. Cool? Awesome sauce. You can always check both and pick the larger of these two. See how I picked the 1/4? That's bigger than that. Okay? So, alrighty, wonderful. We'll do another one of those in class, though. Alright? Let's do another problem, shall we? I think we shall. All right. And once again, we're going to find the restrictions on x. But this time we're dealing with angles, okay? At least for the algebraic part. So I have AC is greater than BC. So AC is greater than BC. So I'll put 2 tick marks and 1 tick mark. Well, that means that angle A is going to be the smaller one compared to angle B. The larger angle will be across from the larger side. The smaller angle across from the smaller side. Wonderful. Does that sound good? Jenny, how we doing over there? Do we need a little Jenny update? Hold on. Let's get this bigger. Hold on. Here we go. What up, Jenny? What's going on over here? You catching anything? Get any squirrels? Anything in the yard? Okay. Apparently not. Wonderful. Back to the math. Back to the math at hand. Cool. All right. So let's set up our inequality. B, which is 7x plus 2, is greater than 3x plus 10. Cool? Jenny wanted to be the part of the video. What up, Jenny? Okay, that's all. Let's solve ourselves an inequality, shall we? All right. Jenny actually doesn't know how to do that, so I'm going to be the one that has to do that. So we're going to subtract 3x, and I get 4x over here. I'll subtract 2 as well while I'm at it, and that's going to be 8. Divide by 4, and I get x is greater than 2. All right. So x is larger than 2. Wonderful. So I don't even have to worry about anything going negative, right? Or going to 0, because I have x's larger than a number, therefore the angles will keep just getting bigger and bigger and bigger. But can angles keep getting bigger? Can angles keep getting bigger and bigger? Does that make sense? Okay. There is a restriction on that, right? The total amount of angles in any triangle is 180 degrees. So whatever these two angles are, they have to be less than 180 to make sure that we have room for angle C to join the triangle party, yes? So even if they just leave it a degree or even a half a degree, C can be a part of that triangle. So I have to make sure that my sum, the 7x plus 2 plus 3x plus 10, is less than 180. So that's the other half of this one. We've got that one there. We don't want to lose that. So let's solve that. I've got 10x, and then I'm going to have, that's 12, so I'm going to subtract that from 180. I get 168. So x is going to be less than 16.8. Cool. So now my final answer with this one is x is between 16.8 and 2. All right. Now, a question for you. If we were dealing with the sides, could they keep getting bigger? Meaning, could I have just said x is greater than 2 and leave it at that? Yeah. My sides of my triangles can get infinitely larger. It does not matter if all three of them are growing at the same rate. But my angles, they are restricted by that sum of all the interior angles of a triangle being 180 degrees. So I do need that upper bound in this one that I have to come up with. All right. So we practiced an upper bound. We practiced a lower bound. I think we're ready to move on from these. All right. Let's see here. So the triangle ABC has vertices A, B, and C, those points. If BM is a median, find the coordinates of, forgot to finish this, of M. Okay. So if I had this triangle drawn out on a graph, which I could do, we don't have to, but I'm just going to draw at least a triangle A, B, C. If I have a median BM, well, where's that going to be drawn from? Where is point M even on this thing? Well, if I start at B and I draw to the opposite side, the midpoint of the opposite side, that's where M would be. Okay. So what am I finding the midpoint of? I'm finding the midpoint of A and C. So let's do that. Well, my midpoint formula is the average of the x's, so 2 plus 5 divided by 2, and the average of my y's, 1 plus 3 divided by 2. That was kind of a voice crack. All right, so I got 7 divided by 2 is 3.5, or 7 over 2, and then I've got 4 divided by 2, which is 2. Boom, I've got my coordinates of M. Easy peasy. Just got to know what it means. A median gives me a midpoint, and then from a midpoint, I can get two congruent segments, or in this case, find my coordinates of it. But if I didn't know how to draw this or where it went, I would be very confused as to what the heck I even need to do. So knowing the terminology, very helpful there. Wonderful. All right, let's do maybe a proof or two and then call it a day on this thing, because Mr. Allen needs to play with River Dog J in the backyard. All right, so what do we got here? We've got angle C and angle B are congruent. D is a midpoint. What does that give me? D is a midpoint, gives me congruent segments. Wonderful. Fantastic. Awesome. Dope. Alrighty. So I've got an angle. I got a pair of sides. right? I would need to explain that, of course, the midpoint thing, but I'm looking good so far. Oh, couldn't I just do AD is congruent to itself and call it a day? Ooh, that is not side angle side. That's side side angle or angle side side, and we do not want to write that because it is not a way we can prove triangles congruent, as we discussed in class extensively. All right, so that's out of it. If only there was something new that I recently learned that could be helpful here. Ooh, how about this? ACB is one triangle. If I have the angles, the base angles, then my sides are going to be congruent as well, right? If angles, then sides. So these bad boys are congruent by side angle side. In the past, we would not have been able to prove this one. We wouldn't have the information to do so, but we do now. That is exciting. The knowledge is power, right? Knowledge is really power. I'm going to go with a green marker now because that's exciting, right? Right? So let's see here. Got my given. I'm not going to write that. Ain't nobody got time to write that. Ain't nobody got time for that. All right. So let's see here. CD is congruent to BD. Definition, midpoint. And think about this. I could have given you that AD is a median, and then you would have to tell me that D is a midpoint, and then you could say that the two segments are congruent. So that's a way to add a step to this thing, a little bit of a difficulty bump, if I wanted to do that to use. Okay. But for this one, we had the midpoint, got my congruent segments. I'm moving on with my life. AC is congruent to AB. If angles, then sides. And then lastly, I've got my proof. Triangle ACD is congruent to triangle ABD, and that is SAS. Coolio. All right. I think we should do uno mas proof, and then I think we're going to be good to go. But I will get a drink of water first. Actually, I left my bubba at school, so I'm just using, the Darwin swag that I got from Jenny. It keeps it nice and cold, though. But yeah, I got to get my bubba when I go back to school on Monday. I don't know what I'm going to do all weekend without it. All right. Let's move on. All right. Last proof here. So I've got a circle. That's fun. Circle O. Then it says that OC, very sloppily, OC bisects angle AOB. Sorry, where were we? Aubrey called and then said, hey, let's order a pizza. So I just ordered the pizza. Now I lost where I was. Anyways, I'm looking forward to that pizza. We're going pepperoni pizza from the place down the street. We order it extra crispy, and it just turns out just perfect. All right. Anywho, OC bisects angle AOB. Well, that tells me that these two angles, I'll call them 1 and 2 for ease, yes, because I can do that. I have the power to do that. Those two are going to be congruent. By definition, bisect. Cool, awesome. What do I know about circles? I know that my radii are congruent. Boom. AO, BO, going to be congruent. That's a lot of information. I don't even know what I'm trying to prove right now. AC is congruent to BC. Well, maybe I can get these two triangles congruent and use some CPCTC to do so. Yes? All right. Well, it looks like I got OC is congruent to itself. Side angle side once again to get these triangles congruent. Oh. So now we have congruent triangles. We can finish this thing up. Let's do it. Statement, reason. 1. Given. Dose. All right. We'll say angle 1 is congruent to angle 2. Definition, bisect. 3. I've got AO congruent to BO, and that was all radii congruent. 4. Reflexive property, everybody's favorite. It's like a gimme. It's like a freebie. We do misuse it from time to time, though, so don't overuse, because it's only if a side is shared by two triangles. That's really the only time you ever use it properly, that is. Reflexive property. And now I've got my triangles congruent. So I've got triangle AOC is congruent to triangle BOC. That is side angle side. And lastly, step 6, AC is congruent to BC, and that is CPCTC. All right. That's about as long as we get on proofs on quizzes and tests right now. Likely would have given you something else. Maybe we would have given you 1 and 2 were congruent, so it's one less step. Again, so this is really at the top level right now of what we're going to be assessing on. So if you're feeling okay on this, you're doing awesome. If you're like, well, that was kind of a bit, we might have them a little bit short, a little more manageable, but still, a relatively doable proof, nothing too crazy out of the box like some of the ones you've seen in homework and stuff like that you're like, whoa, bro. What's happening? All right, I want to do one more with the inequalities, and then we're going to call it a day on this video. If you're still watching, I hope you're still watching. I'm having a great time. It's really a lot of fun here. All righty, last one. So we have BC is larger than AB. BC is the larger one compared to AB. Well, that would mean that angle A is my larger angle compared to angle C. Okay. So now I can set up an inequality with these two measures. So I would have 3x plus 6 is greater than 5x minus 4. And when I solve this, I add 4, I get 10 over here. I subtract 3, I get 2x. And I do that to keep them positive. I think actually some of you might be a little bit more comfortable doing this. Subtracting 5x, getting negative 2x is greater than negative 10. Divide by negative 2, because a lot of people like to keep the x's on their left-hand side, and that's cool with me. Just make sure then, because you have the negative, that you flip the inequality. And then we have divided by negative 2, that becomes positive 5. So x is less than 5. All right. And you would have gotten that the other way as well, but I think more of you probably keep the x on the left as you were trained to do in Algebra 1. All right. Now, x is less than 5. Well, if I keep getting smaller and smaller and smaller, I have the potential to get to 0 or negative number. I don't have to worry about that whole 180 thing on this one because my restriction is already above. But my lower restriction now is 0. So I got to think about this. Well, I got to make sure both of these angles stay above 0, right? So this one needs to be greater than 0, and this one needs to be greater than 0. Now, I can save myself a little bit of algebra time if I pick the correct one. Let's think about it. Which angle is smaller? Angle C is smaller, right? So if angle C is greater than 0, angle A has to be greater than 0. And I feel like I kind of butchered that in the last time explaining it, so hopefully this makes more sense. As long as angle C is greater than 0, angle A has to be, because A is bigger than it. So let's take the 5x minus 4, set it greater than 0, add 4, and I get 5x is greater than 4. Divide by 5, and I get x is greater than 4/5. So my final answer here, x is less than 5, greater than 4/5. That is dope. Gucci. Super awesome. And if this were an item of food, I might say that it is bussin'. Okay, so hope you guys have a wonderful day and a wonderful weekend. Whenever you might be watching this, it might be before school on Monday. I don't know when you're going to watch this, but I hope whatever day it is that you are having a wonderful day. America Freedom, rock and roll, Costco, Riverdog J and the Gram. Deuces.